If it is product, initially with respect to the product, rate is 0 because in the beginning there is no product at all. So rate of the formation of the product gradually increases. That's why the rate we are getting, there is a gradual increase. So that's why overall we can say the concentration of the more relevance or directly proportional to the rate of a chemical reaction. And coming to second case, second aspect, nature of the reactants. Generally, if you come across about chemical reactions, for example, you take the same example what we discussed in the here previously, while considering the rate. I told you just mix two components like aqueous solution of AgNO3, silver nitrate, and aqueous solution of the sodium chloride. Take these two in a separate beakers, okay, and mix these two slowly. The moment these are mixed, we can observe the instantaneous formation of the corresponding white precipitate of the AgCl, silver chloride. At the same time, and you take any reaction, suppose you take again the reaction between the hydrogen gas and oxygen gas. Okay, the reaction is very slow, as I already told you here. And the first case, the formation of AgCl is instantaneous. In second case, the formation of water from hydrogen and oxygen is slow reaction. This will try to understand, like in the first case, AgCl, it is ionic. NaCl, AgNO3 is ionic, and NaCl is also ionic compound. So when we mix these two, so immediately we can observe the formation of the AgCl. That means from this we can conclude that whenever a chemical reaction is between the ionic compounds, those reactions are very fast. And if the reaction is between the covalent molecules, the reaction is slow. In the case of the covalent molecules, definitely the existing bonds must be cleaved, broken. After breaking the corresponding covalent bonds, new bonds will be formed. That's why whenever we come across about the reaction between the covalent molecules, definitely the rate will be slow because the breaking of the existing bond will take place and the formation of the new bonds will generally occur. Both involves some time. That's why always the reaction between the ionic compounds is very fast, and the reaction between covalent molecules is generally slow in nature. That's why you can see here, this is about the nature of the reactants. So simply ionic compounds will react faster. In the case of the covalent molecules, the reaction is generally slow. And coming to temperature, it is observed that whenever we increase the temperature, the rate of reaction increases. This is according to the collision theory, which is given by Arrhenius. According to this collision theory, whenever we increase the temperature, the molecular collisions also increases. When the molecular collisions increase, automatically the rate of reaction also increases. It is also observed that for every 10 degrees rise in temperature, the rate of reaction got doubled. So if you take the rate or the specific rate of a chemical reaction, which is K, at a temperature of T plus 10 degrees Celsius divided by the temperature at T degrees Celsius. So what difference between these two? This is a temperature T degrees Celsius. This is temperature T plus 10 degrees. That means there is an increase in temperature of 10 degrees. So as I told here, for every 10 degrees rise in temperature, the rate of reaction get doubled. That means the ratio of these two will becomes equal to 2. This we call this as how we can represent this? This we call it as a temperature coefficient. Temperature coefficient. So it is a ratio of the specific rates of the corresponding reactions or corresponding specific rates which have that or which are measured with the temperature difference of 10 degrees. So what is the conclusion here? It is observed that for every 10 degrees rise in temperature, the rate of reaction gets doubled. So actually here this K generally represents specific rate of the reaction. This is at temperature of T plus 10 degrees Celsius. So this is the temperature of T degrees Celsius. So different temperature is 10 degree. That's why for every 10 degrees rise in temperature, the rate of reaction generally gets doubled. This effect of the temperature. And coming to the catalyst. So in general, catalyst is a substance which alters the rate of a chemical reaction. Here we are saying alter, the reason is some of the catalysts will increase the rate of reaction. And we have few catalysts, they can also decrease rate of a chemical reaction. So mostly generally we use the catalyst to increase the rate of reaction. So whenever a catalyst increases the rate of reaction, we call it as a positive catalyst. And when a catalyst if decreases the rate of reaction, it is called as a negative catalyst. So we can say here there are two types of catalyst here. So one is positive catalyst which will increase the rate of reaction. The other is the negative catalyst which will decrease the rate of a chemical reaction. In general, most of the cases will use the positive catalyst. For example, we have seen, you are aware about the Haber's process. In the Haber's process, generally we use finely divided iron as a catalyst where the nitrogen gas combines with hydrogen gas to give the ammonia. So generally the reaction is more favored towards the formation of the ammonia in presence of the catalyst which is the finely divided iron. So iron is used as the catalyst. At the same time, suppose we take hydrogenation of oils. So where these are having the multiple bonds. Okay. So when they react with hydrogen, generally we use certain catalysts like nickel, platinum, palladium. So which leads to give the fats, which we call it as a Vanaspati process. So in the respective cases we are using many catalysts. So generally the role of the catalyst whenever we are using it as a positive catalyst means what it will do is it will change the path of a chemical reaction. So when path is changed, exactly what happens means in any chemical reaction whenever there occurs molecular collisions, what happens is some energy barrier will be present in every chemical reaction. So that energy barrier is decreased in presence of a catalyst. This will facilitate the chemical reaction to occur faster, which will give the products quickly or easily or in small interval of time. That we generally call it as a positive catalyst. Anyway, I told you negative catalyst also. For example, if you take the hydrogen peroxide. So hydrogen peroxide should be stored in plastic bottles which are coated, especially otherwise we can store the H2O in the wax coated bottles. And while storing hydrogen peroxide, we use certain ingredients like which will generally prevent the decomposition of the hydrogen peroxide like urea, acetonilide. If they are not present, what happens is the decomposition of H2O2 generally will increases. So in presence of these components like urea, acetonilide, what happens is the decomposition of H2O2 will be decreased. So in this case, these we can call them as the negative catalysts. Negative catalyst. Anyway, so in presence of the positive catalyst, here the energy barrier or energy of activation will be decreased. So because of this reason, the reaction rate becomes faster, so products will be formed with more speed. Okay, and coming to the presence of the light. So generally this is this particular concept, or generally we can observe only in the case of the photochemical reactions. In the photochemical reactions we need the sunlight. So most of the photochemical reactions are in general they are free radicals. In such a case, this particular light have effect. At the same time, surface area of the catalyst especially. Here, suppose I told you just now, in the case of the Haber's process, we are using the finely divided iron. In the case of contact process, we use vanadium pentoxide, V2O5. So whenever we use here, for example, in the Haber's process, we are using the finely divided iron as a catalyst. So because why we have to use the finely divided catalyst means The finely divided catalyst, if you take, every particle of the catalyst can act as a surface so that it will increase the rate of reaction. If you use coarsely divided one, what happens in such a case, the surface area will be very less. So that's why whenever we use the catalyst with more surface area will automatically increase the rate so that the product will be formed with faster. Okay, so these are the factors which influence the rate of a chemical reaction.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.